Good morning or good afternoon, everybody. I'm going to summarize a bit some of the activities, the data and the tools that we develop at the Copernicus Climate Change Service that are related to the extreme events and explicitly in the context of adaptation to climate change and attribution. So I'm going to share my screen. Please let me know if you may see my screen.
Yes,
and my presentation in full mode. Okay.
Fine. Thank
you. Okay, so studying geophysical extreme events is, of course, absolutely important in terms especially of their impacts. Let's say that the variety of extreme events is enormous. If we think, for example, of the way they manifest or where they manifest or their length, and of course, their impact. In this slide, I'm reporting some numbers from the WMO Atlas of impacts from extreme events. And extreme events have caused loss of lives and enormous economic damages. And here I'm referring to extreme events that include droughts, floods, windstorms, tropical cyclones, storm surges, and extreme temperatures, among others. So let's say that understanding of the extreme events is becoming a priority. And this is especially in the context of the climate crisis. And I would say that we need, in this case, for making a step forward, both an empirical knowledge, but also advancement in the basic knowledge. The word extreme has, of course, many different meanings. And in general, we may say that in this context, it may be used to identify something that it is very rare or something that is very large or even maybe very small, but also something with a very high impact. And of course, those three concepts are overlapping, but they are not the same. So when studying extreme events, we take into consideration the timescale of the system, but also the temporal length and the spatial extent of the event. So, for example, thinking of slow onset events such as droughts or cold spells or heat waves versus fast events like flooding or tropical cyclones. And for studying this kind of events, of course, we need data. And we need data and we need tools. And of course, those data and those tools have to be fit for purpose to study such events. And this means, of course, some technical characteristics of the dataset, such as the high spatial and temporal resolution, or, for example, an extensive time coverage, thinking of characterizing extreme rare events, but also quality related to temporal homogeneity of the data, presence of drifts and breakpoints in the datasets, or characterization of known biases. And finally, also the usability of the dataset is quite important. So, are the data accessible? Are the datasets maintained? Or are they provided in near real time? Or are those evaluated and quality controlled? And all those concepts, of course, let's say, connect to the concept of an operational service. So, the Copernicus Climate Change Service is one of the 6 services of the Copernicus program. And the Copernicus program is the program for Earth observation to monitor Earth and the environment. Different satellite data are becoming available and will continue to become available within this program. Data are free, are open access, and they are accompanied by quality information. And C3S, the Copernicus Climate Change Service, is one of the 2 services that is operated by ECMWF on behalf of the European Commission. So what does C3S, the Climate Change Service, offer? So it offers open and free access to climate data. It offers tools needed to use the data. It offers information on sectors, quality assurance, user support and training, climate change assessment, as well as outreach and communication. And all those activities are done in an authoritative, but also standardized way. And I think that here, in this case, standard is really a keyword. So if you think, for example, of extremes, we need reference data, but we also need standard methodologies. And this is what the C3S operational service offers. So in practice, it offers data and tools that are found in the climate data store that is here, a one-stop shop for data and tools. So we think of the data and we go back to the reanalysis. So the data that were mentioned in the previous two presentations by Guido and Antonio. Of course, we have available a huge variety of data in the climate data store, but reanalysis are among the most used data set also for climate extreme studies, and mostly because of their popularity. So their popularity is because the data set is complete in the sense that it combines a vast amount of observation into global fields using the data simulation technique. The data set is consistent because reanalysis combines model data with observations from across the world into a globally complete and consistent data set using a model, the laws of physics. And they use the same physical model and data simulation throughout the entire procedure. The data set is convenient in the sense that there are maps without gaps. So they are always available in the same way to the users. And it is very important to say that observations are absolutely key in this context. So their availability has evolved drastically over time, and evolving observations are making the dataset more reliable and much more at higher quality. So here I focus just on the two sets of reanalysis. The E³CI is a full observing system global reanalysis for the atmosphere, land and ocean waves. E³CI has replaced the previous generation of reanalysis that are named the E³Interim. And in this sense, it is a better product because it has a better model behind, it is developed and it is delivered at a higher resolution, more and better input data are included. So it is available from 1950 onwards, as also Guido was saying, and it is daily updated 5 days behind real time. On the right-hand side, you may see a map of a climate anomaly for the last December 2020. So just to remind you that the 2020 entire year was the warmest year on record for Europe. Together with E³CI, you may find in the climate data store also E³CI land. This is a dynamical downscaling until 9 kilometers, as Guido was also mentioning. And of course, you may understand that in this case, a better representation of the orography is delivered. So in order to show you quickly the difference between the previous E³Interim system in the context of extreme events and the new E³CI, I'm showing here an animation of one hurricane, the Hurricane Florence, hitting North America in 2018. On the right-hand side, you have the new generation reanalysis. You may see several improvements compared to the E³Interim. So thinking of a much higher resolution, 30 kilometers versus 80 kilometers, hourly output. So each step in the animation is the time step of the model. Now the colors here represent the accumulated precipitation from the starting of the animation, whereas the line, the black line represent the mean sea level pressure. Of course, let's say that this data set is better also because it benefits from additional more years of research and development with respect to the previous one. And it is delivered in near real time. But let's say that the highest quality is found over data-rich areas. The global reanalysis are not the only reanalysis available in the climate data store, but I do not have time to show you the regional reanalysis. So what we do with those climate data, and of course many other data that are available in the climate data store. So first, we extract climate information from data and we transform it into knowledge. So the infogram on the right-hand side of this slide represents the service chain from the data to the information. And there are two typologies of product. On the top, shown our activity of climate monitoring. So I'm talking about reporting the climate at monthly scale. So we have monthly bulletin, but also a nearly European state of the climate. And there is a section dedicated to the extremes. And in the bottom, you see instead the service chain that produces climate knowledge that is instead relevant for supporting adaptation strategies in different sectors. And of course, those many sectors are vulnerable and climate actionable sectors. So for example, we estimate and when we try to reduce the risk associated to pluvial flooding, or the levels of risk from the windstorms may become relevant for the insurance sector. Or again, extremes are very important in defining the standards in infrastructure for making resilient buildings, or extremes are very important, of course, in connection between health and heat waves. I will show you just one only example coming from those activities, and this is in a collaboration with CMCC. So this activity has the focus of developing data sets, even at a quite high resolution, tools, but also applications to provide a set of climate impact indicators that are related to the extreme precipitation. And of course, also to assess the magnitude of past extreme precipitation events across Europe. But also it has the ambition to make an evaluation of the spatial distribution of flood hazard and damages related to those extreme events over some specific European cities. And the maps that you see here are just an example of the indicators related to the extreme precipitation. So the last activity that I would like to quickly mention here is instead the development of a prototype service for extreme events and attribution. So here, the ambition is really to provide a wide range of users with timely and reliable information about extreme weather events, and especially how they relate to anthropogenic climate change. And on the right-hand side, there's this infogram that is showing for which extreme event typology we have a better understanding of the effect of climate change, and therefore for those typology of events, we may build a more reliable attribution service. So to conclude my very short summary, the data with respect to extreme events here, I've mentioned the reanalysis, and of course, reanalysis provide maps without gaps, and they are able to deliver consistent estimates that are based on the entire observing system. And the EC&WF vision for C3S after 2020 is to continue to allocate high priority to reanalysis, and there are also regional reanalysis that I've not mentioned in my presentation. Of course, our intention is also to look at extremes in a quite more consistent way in our program and across the different services. So we will continue to maintain operational service components such as the monitoring of the climate, but also information on sectoral impacts. And I would like to highlight that more than focusing on data, in this case, we would like to really focus and deliver tools that are tailored for dealing with, for example, extreme events. Finally, we are already liaising, and we will continue to liaise with the climate adaptation portal. Here, I'm referring to the connection with the European climate adaptation platform, Climate Adapt, that's in partnership with the European Commission and the European Environment Agency. Finally, we would like to develop an extreme event catalog in collaboration with the Copernicus Emergency Management Service, and of course, maintain an operational extreme events and attribution service. And I thank you